Hey, so are you trying to learn more about Java input output? If so, this video is for you. So in this video, I'll go over multiple topics, including what is input and output, what is IO, basic input operations, basic output operations, file input and output, exception handling in IO operations, best practices, and some coding examples. As always, my videos are timestamped in the description, so if you came here for a specific topic, you can skip to it. So, how about we get right into it and let's tech talk with Tyler. So, Java IO, or input slash output, forms the backbone of how Java programs interact with the outside world. It encompasses the processing of reading and writing data, allowing programs to communicate with users and external systems. So, understanding the flow of data into and out of a program is crucial for any developer. So, input operations enable programs to receive data, whether it's from a user's keyboard input or an external source, fostering dynamic interactions. On the other hand, we got output. And output operations allow programs to display results, making them meaningful and valuable to users. At the end of the day, if we didn't have input and output, software would not work. What would be the point? So, Java provides a robust framework of classes and packages for handling these IO operations. These include a variety of streams, readers, writers, and file manipulation classes, each serving a specific purpose. Let's get into some fundamental aspects of basic input operations in Java. First, we have the input stream and buffered input stream classes. So, what is input stream? Input stream is a fundamental class that serves as the base for reading binary data from various sources. It's not used so often, so don't fret. When combined with buffered input stream, which is used more often, which adds buffering capabilities, these classes become powerful tools for efficient data reading. Moving on to the scanner class. So, the scanner class simplifies the process of reading data from the console. It allows programmers to parse different data types like integers, floats, strings from user input, making interactive programs user friendly and versatile. Additionally, the buffered reader class offers efficient reading of characters and lines from input streams. So, by buffering the input, it significantly enhances performance. Buffered reader provides methods like read line, enabling the reading of complete entire lines of text, which is useful when dealing with textual data. So, we just discussed input operations. On the flip side, let's discuss some core concepts of basic output operations. First, we have the output stream and buffered output stream classes. So, oppositely of input stream, output stream serves as the foundation for writing binary data to different destinations, while the buffered output stream just enhances efficiency by adding buffering capabilities and optimizing writing operations. Moving on to the console output, we have the system.out stream, which is the standard output stream in Java. It plays a vital role in displaying program outputs, error messages, and other relative information on the direct console. Programmers commonly use this stream to communicate with users through command line interfaces. So, lastly, the print writer class just simplifies the task of writing characters and lines to various output streams. It provides convenient methods for writing different data types and automatically handles character encoding. The file class plays a pivotal role in file manipulation. It serves as a bridge between Java and the underlying file system, offering methods for creating, deleting, checking, existing, and retrieving information about files. So, this class is pivotal for managing files in Java applications. So, when it comes to reading data from a file, Java offers file input stream and file reader classes. So, file input stream reads raw bytes from a file, making it suitable for binary data, while the file reader interprets these bytes as characters, making it ideal for reading text files. So, these classes enable the extraction of data from files, facilitating data processing tasks. On the flip side, for writing data to a file, Java provides file output stream and file writer classes. The file output stream writes raw bytes, allowing developers to create or modify files with specific binary content. File reader, on the other hand, writes characters, enabling the creation and modification of text files that you and I could read. With IO operations, exception handling is crucial as it ensures that programs gracefully handle unexpected situations. So, firstly, understanding common exceptions in IO operations is essential. IO exceptions is a broad exception that encompasses various issues like file not found, permission problems, or unexpected end of file. So, being aware of these exceptions help developers anticipate potential problems in their programs. When it comes to handling exceptions, Java provides the try catch mechanism. So, within this try block, developers place the code that might throw an exception. If an exception occurs, the program transfers control to the corresponding catch block, where developers can specify the actions needed to respond to the exception. Proper use of a try catch block ensures that programs can identify and respond to errors effectively, thus preventing crashes and enhancing user experience. So, in terms of best practices, it's crucial to provide informative error messages when exceptions occur, such as clear and descriptive messages. And these just aid the developer in knowing what exception they wrote for and also help the user know what went wrong. Also, logging exceptions is essential for analyzing issues that occur in real world applications. So, by properly releasing resources such as closing streams and files, even in the presence of exceptions, it's vital to prevent resource leaks, ensuring the efficient use of system resources. I wanted to create a full slide on best practices. So, first, the try with resources statement is a powerful tool for automatic resource management. So, by using this statement, developers can ensure that streams and other resources are automatically closed at the end of a statement, which simplifies the code and eliminates the risk of resource leaks. Properly closing streams, readers, and writers is another essential practice because failing to do so can lead to resource leaks, consuming valuable system resources. So, by ensuring that these resources are closed correctly and in a timely manner, developers prevent memory and file description leaks, ensuring the smooth functioning of their application. So, handling different types of character encoding is critical, especially in a globalized world where applications interact across various platforms and systems. So, in this coding snippet, I have 6 different import statements at the top here. So, we have the import file writer, and this is used for writing character files or streams of characters. Next up, we have the import IO exception, and this is a general class of exceptions produced by failed or interrupted IO operations. Next up is the buffered reader, and this reads text from a character input stream, buffering characters to provide for the efficient reading of characters, arrays, and lines. And then we have the file reader import statement, and this is used for reading character files and streams of characters. And then we have the util.scanner, and this is a simple text scanner which can parse primitive types and strings using regular expressions. And then we have the J option pane, and this makes it easy to pop up a standard dialog box that prompts users for a value or informs them of something. So those are the 6 import statements that we will be using within one or multiple of these examples that I have here. So let's start with the first one. So the first one, we will be writing data to text files. So let's start with the main method. And let's set a string variable called data. And let's just declare it as hello world. So let us use the try with resources statement. And what this will do is it'll ensure that and we will be writing the file name that we're going to write to, which is going to be output.txt. And we'll call the writer. And what we want to do is write. So we're going to use the write method. And we will just write what we have in the data field. And let's just say that the data was written to the file successfully. But now that we have the try block, let us create the catch block to catch any IO exceptions. IO exception, and we'll just name this E. And then we will print out an error occurred while writing to the file. And then let's write that error that did occur. So E dot, and we will use the get message method. And there we have it. So in this example, the string hello world is written to the file name output.txt. If an error occurs during the write operation, an IO exception is caught and an error message is displayed. So moving on to the next example, we have append data to existing text files. Let's create another main method, and let's create a string data variable equals, and let's say new data to be appended. And let's use the try catch block again. File writer equals new file writer, and we will be appending to the output.txt file that we created and we wrote to in the first example. And what are we going to append? True. We're going to write again, write data, and it's a string. All right, and then let's catch this. So catch, same thing that we did in the first example, IO exception. We'll name it E, and we will do the system.out.println and let the user know that an error occurred while appending to the file. I think I spelled occurred wrong. I did. I need another R. And then we will append the file. We will append the error message, so e.getMessage. And that's that. So this Java program demonstrates how to append data to an existing file using the file writer class with the Boolean parameter true, indicating the append mode. The try with resources statement ensures proper resource management. If the file does not exist, a new file will be created. The string new data to be appended is appended to the file named output.txt. All right, so moving on to the third example, we have read data from existing text files and detect end of file. So we have public class read file, and within that class, we'll create a main method, and we will use the same try catch statement that we did in the previous two examples. And we will use the buffered reader. Let's initiate it, equals new buffer reader. And we have new file reader. And what's the file name? Input.txt. Let's create a string called line. And what we'll do is we'll create a while statement. So while line, and then we will read each line while the line is not null. That's what we're doing here. So while line equals reader dot, and then we're going to use the read line method, and then we're going to say does not equal no. What are we going to do? We will print the line. And so what will stop this while statement from executing? What will stop it from executing is when the reader.readLine reads the next line and it is null. It will leave this while statement. So once it leaves this while statement, we know that the end of file has been reached. So we could say that here. And there we go. So that's the try block. Let us catch now. Catch IO exception, and we'll name it E. And we will just print an error occurred while reading the file. And let's just give the error message, e.getMessage. And there we have it. So this Java program reads data from an existing text file named input.txt using the buffered reader class. And keep in mind, the buffered reader class reads text from a character input stream, buffering characters to provide for efficient reading of characters, arrays, and lines. So the program reads the file line by line until the end of the file is reached, which is when read line returns null on line 43. Each line is printed to the console on line 44. If an error occurs during the read operation outside of this try block, we'll catch it with an IO exception and an error message will be displayed, lines 47 and 48. All right, so let's move on to question number 4, I believe. Request input from the user using the scanner class. So we have public class user input. Let's create the main method. And so we'll use the scanner class. So scanner, let's initiate. Let's just say scan equals new scanner. And we will say system.in. And so the system.in is passed as a parameter in scanner class, which just tells the Java compiler that system input will be provided through the console or the keyboard. And let us print enter your name. And we'll create a string variable called name equals scan, which is what we named the scanner. So scan dot, and let's see, which one would we possibly want to use for a name? Let us use the next line. Sometimes people will enter their first name, Tyler. Sometimes they'll enter their full name, Tyler Crawford. So we'll read in the next line, and then we'll print again and just say hello, and then plus name plus a period. And then after we read the next line, we must close. So we have to say scan dot, and then let's close. And there we go. So this Java program demonstrates how to request input from the user using the scanner class, lines 56. The program prompts the user to enter their name. The next line method reads the input as a string. The entered name is then displayed as a greeting message. And then the scanner is closed to release system resources after use. Example number 5. So we will be requesting input from the user using JOptionPane class. So we got the class right here. Within that main method, let us create a variable called name equals JOptionPane. Let's use that first one, dot. And what methods do we have? So we want to request input. So we're going to show an input dialog. So let's use this first one. And let us type our message, enter your name. And then now we will do the JOptionPane dot. And now we will show the message dialog. See if we could find it here. Show message dialog. And then we will have null, hello. There's no parent component. The message is going to be hello plus name plus exclamation point. And that is it. So this Java program, fairly simple, just demonstrates how to request input from the user using the JOptionPane class, which provides a graphical user interface from input and output. The showInput dialog method displays an input dialog where the user can enter their name. The enter name is then displayed as a greeting message using showMessage dialog. All right. Example number 6 is to output data to the console using system.out. So similar to how in example number 4, we requested input using the scanner class, this one we're going to output data to the console using the system.out. So inside our main method, we will quite literally just do the system.out.print. You could do print or you could do print line. This one, it really doesn't matter. The only difference with the ln is it'll create a new line, and then we'll just say hello world. And that is the simple program. Very simple. It just demonstrates how to use the system.out.print line. Example 7, output data to the console using JOptionPane class. So this is similar to this one. So I will actually just copy these 2 lines. And instead of using this line here on 88, we will use the JOptionPane class, imported class, and we're going to use the showMessage dialog. It is going to be null. There is no parent component. And then we'll just input the message. So the message is hello world. And this just demonstrates how to output data to a graphical user interface, or GUI, as I say it, using the JOptionPane class. All right, so that is all that I have for Java I/O operations. I hope this video gave you a better understanding. I hope you understand more about it than you did before, and I hope that the coding examples were helpful. Also, if you found all this information helpful, I do create one-page cheat sheets for you to have all the information covered in this video on one page. So if you would like to get your hands on one, go to my website, tylerlcrawford.com, and you'll find it there. I hope you enjoyed this tech talk, and I'll see you in the next one.